Okay, today we're dealing with ambiguous ASS triangles. And when I say ambiguous, because if you remember, ASS from geometry was not a rule you could use for triangle congruence property. For triangle congruence, you are not allowed to use angle side side. Meaning, if I give you a triangle with just the angle, let's say angle A, measurement angle A is equal to 32. And then I give you a side B is equal to, let's say, 8. And then a third side a third side A is, let's call this 7. Angle side side. This was not solvable. It really wasn't not solvable. It wasn't a congruence property because there was a special gimmick to these ASS triangles. It's not that the teacher didn't want you to write this word all over your paper. It's because it gave you two possibilities, like two butt cheeks. Right? Give you two for the price of one. And unfortunately, we have to now learn how to solve for both those versions. My name is Edward, and you guys, most of you guys know that I have a twin brother, and his name is Edwin. Okay, Edward and Edwin. Don't ask why my parents named us twin names, maybe just to mess with people. But if you called Edward, of course I would respond. If you called Edwin, my brother would respond. But if you just call, hey, Ed, who do you want to respond? Or are you just being lazy? You end up with two twins going, what do you want? Okay? Because if you say Ed, there's two possibilities. The same thing here. ASS triangles have two possibilities. Now let's draw this out as an example. We have 32 as angle A. Opposite side A is 7. And I'll call this here B. Okay? And my angle B is here in C. Now, this happens in this special case. ASS is if it's angle, long, and then short. This is the only time ASS gives you two triangles. So angle, long, short. If it goes in this pattern, you have two possibilities. Angle, long, short. If it's angle, short, long, then you only have one triangle. Okay? And this is why. Let me go ahead and show you why. If it's angle, long, short, anyone ever go fishing before? I think of this almost like fishing. So this is me sitting on a lake with my fishing pole, right? This is my fishing pole. And when you have fishing pole and you throw your little cast out, right? But when you throw it, doesn't sometimes swing back and forth like that? So if it swings a little bit like the circle, isn't this over here also 7? So here is the problem with this. If I told you angle 32, 8, 7, sure, we end up with this nice blue triangle. But we also end up with this red triangle. Oh, this blue triangle here. I'm gonna draw. So that probably looks a little better. So this blue triangle here is my second evil twin that we hide in the basement. So I'm gonna draw this out separately right here. And you tell me, do they have the same characteristics? 32, 8, and 7. 32, 8, and 7. And the problem is, yeah, angle, side, side. Now, which triangle is it? In math, we learn to solve for both. Why do we have to solve for both? It's actually an algebra 1 idea too. If you remember x squared equals to 4, how many answers do we get here? What answers give you 4? Well, you probably said 2 already, because 2 times 2 is 4. But also, don't we also solve for negative 2? Right, negative 2. And the way we solve that is we use a square root. When we take a square root, we remember to write plus and minus on both sides. That's why we have a plus and minus 2. We solve for all the possibilities, not just the easy ones. Okay, so today we're going to solve for both these triangles, and I'm going to show you guys a pretty easy way to do it. It's actually pretty easy. So let's go ahead and redraw this triangle. We have two versions of this triangle. So let's draw our first version, which we said was 32, 32, 8, and 7. And our second version is going to be a really fat angle over here, 32, 8, and 7. A, little a, B, little b, C, little c, and A, little a, B, little b, C, little c. Okay, so the second triangle is going to be a little more tight when it comes to us writing numbers. Okay, so this is our dilemma. We have to solve for them both now. So do we have an angle side pair? Yeah, ASS triangles will give you this angle side pair. So if I know this angle side pair, we can solve for this angle side pair, which I see. If I know side B, I can find angle B. Sine of B over 8 is equal to sine of the angle that we know, 32, over the pair that we know, 7. Does anyone have a question how I set this first fraction up, please? If you need help, please raise your hand. I can go over something if you're shy. Just click a no. Okay. So this is all calculator work. Sine of B is equal to 8 sine of 32 over 7. I'm going to take out my calculator. And we're going to write 8 times 32 sine equals divided by 7 equals 0.60 is not an angle, please. That's a sine of B. We undo it by inverse. And B is equal to 37.27. Let's use 2 decimal. 37.27 degrees. Great. Now, if we have two angles of a triangle, can I find my third? Of course I can. 180 minus my 32 minus my 37.27. And we have 110.73. All right, and now if I have angles C, I can find side C doing law of sines again. Sine of C over, whoops, we know what the angle is. Get rid of this. We know what angle C is. That's 110.73. Now, when I do this problem, do I like writing the variable on the bottom? No, right? So we want to spin that around, okay? I'm going to write C over sine of 110.73 is equal to the side that we know, 7 over sine of 32. That's what we want to do. And you can solve this using your calculator again. So how do we get to that second version of the triangle? Because if I set this problem up, this is what's going to happen. If I write solve for B, sine of B over 8 is equal to sine of 32 over 7. Look at this answer here. Aren't they exactly the same? Wouldn't it give me the same exact answer? Solve for B using A. Solve for B using A. Yeah, it would still give us B is 37.27. Look at B. Is that a 37-degree angle, or does that look a lot bigger than that? If you look at angle B, it's what we call an obtuse angle. It's an angle larger than 90 degrees, and that's our problem. So how do I get from 37 to this fat obtuse angle? Let's go ahead and look at how. let's go ahead and draw you guys the triangle again. We said this was 7, and I'm going to draw my second triangle right here. This is 7. We are trying to aim here. This is our target right here. This is our target. Trying to get here. Okay. This is our, call it B prime if you want, however you want to call it. This is B. This is our little B prime. We know that the right angle B was going to be 37.27. Now here is the gimmick for us to get there. Look at this overall triangle here. What type of triangle do we call a triangle with two exact same sides? We call it an isosceles triangle. And if a triangle is isosceles, if the sides are congruent, hopefully you remember geometry, if the sides are congruent, so are its base angles, 37.27. Now, if you look at angle B prime that we're looking for, as well as 37.27, aren't these here a full line? So that should add up to 180. So here's what we do. We just say 180 minus 37.227. So measurement angle B. Take out my calculator. Now I don't need a calculator. 142.73. 142.73. So my new angle here, B, will be 142.73. And that looks like the obtuse angle we were looking for. So here is the takeaway. If you get an acute angle, but the angle looks obtuse, it's because it's probably an ASS triangle. And this ASS triangle, you're looking at the wrong dimension. How do we get to that second dimension? You just minus 180. Sorry, my audio died on my tablet. I don't know why. But, oh, it's because the feed froze. Give me a sec. Okay, so the big takeaway is once you find this angle that's too small to fit in this big angle here, you just subtract 180. So that's what we're going to go back to our problem. So in our problem before, we said, hey, I got 37.27, just minus 180 from that. We end up with 140 point, darn it, I'm not even thinking, 142.73. 142.73. So our angle B prime is 142. And then how do I find my third angle? We say, hey, I know 32. I know 142. We subtract that from 180. And that last C angle is actually going to be pretty tiny. So 32. Oh, let's go the other way. Let's do 180 minus 32 minus 142.73 equals, and we're left with a very tiny angle, 5.27. And if I have my last angle, I can find my last side. So to finish this triangle, let's go ahead and finish it over here. Side C is equal to sine of sine 27. So over. Sorry, undo this. sine of 5.27 is equal to 7 over sine of 32. This is calculator work. 7 times 5.27 sine that equals divided by 32 sine. And it gives our final side 1.21. Okay, so with the last 7 minutes, I'm gonna go ahead and do the prompts you have for your homework today. One is an IXL, the other one is a open math problem. Let's go back there. Let's see, open math. So the first homework problem is this part, problem number 1 and number 2. So this first problem here, I want you guys to ask the first question. Is this a law of sines or law of cosines problem? That's usually what I say. I don't say ASS. I just say law of sines, law of cosines. Hopefully you realize that an angle side pair here, that's law of sines. And then I actually don't think about the problem. I just start solving. Okay, I don't think this is an ASS problem. I don't think there's 2 possibilities. That's not the first thing that comes to my mind. I just start solving. Let's go start solving for A. Sine of A over 26 is equal to sine of 20 over 17. How do you guys feel about this, the setup? Law of sines? And then we end up with sine of A is equal to 26 sine of 20 over 17, just moving the 26 over by multiplication. Now we're just going to take out my calculator and do the work on the calculator. 26 times 20 sine equals divided by 17, and we're left with 0.52. That's not an angle, so we just inverse that, and A is equal to 31.54. That's round up. Now, you could write 31.54, and you will get it wrong. Because this is the part where when you think about your angles, think about your answers, and see if they make sense comes into play. Is 31 degrees a small angle or a large angle? Ask yourself, is 31 degrees a small angle or a large angle?
Acute.
Acute. Isn't that a pretty small angle? But look at angle A. That is an obtuse angle. That's a fatty angle. So here's my first mistake. If I just wrote 31, I didn't account for the fact that that angle A is obtuse. So let's go ahead and read the prompt. This is something that I should have done too. If you read the prompt, picture is not drawn to scale. Duh, thanks. But you can assume that an angle that appears acute is acute, and an angle that appears obtuse is obtuse. And angle A looks like it had too many Dunkin' Donuts, and it is pretty obtuse. So how do we get from this angle to this angle? Folks, it's as simple as subtracting from 180. So you have that angle already, minus 180. Oops. I shouldn't have done that part. Messed that up. Okay, let's write down what we do have. Let's do that again. So I'm just going to go the other way. 180 minus the angle I wrote down, 31.54. So it's going to be 100. A is going to be 148.46. And that's how we find the angle A. Once I have my angle A, I see the angle 20, 180 minus 20 minus 148.46. We're left with 11.54. And if I have the top angle, I can now find the side X. It's all about problem solving. It's all about coming up with a way from getting to step 1A to B. Okay, so do I have any questions about this problem? The gimmick is that you have to subtract from 180 to get the angle A, because the angle A you got is acute, but the angle that they show me is obtuse. And we didn't do any of the math wrong. It's just that this was our alternate triangle. The triangle that we were actually looking at was probably this triangle over here. And that's a 31 degrees, but that's not the angle we got. That's not the triangle we got. We got the second version. And that's what we have to be careful of. Again, how would you not make this mistake? And I probably would have made the mistake if I wasn't being careful about paying attention to my answers if my answers made sense. Does the angle 31 make sense for such a large angle? It doesn't. It's the other triangle. Okay. So for our second, there's like 7 questions today. The other questions will take most of your time. But honestly, you can finish these questions in about 5 minutes each once you're used to it. Maybe a little bit less, depends how fast you can type. So they told us the basic triangle is, so I'm going to draw my own triangle here. So I'm going to draw a triangle, like I'm used to. This is 47. Side A is 34, and B is 35. Now, if you look at the setup once I draw this, is this an ASS triangle? Angle, side, side. Crap, it is. Is it angle, long, short? Ah, crap, it is. That means there's for sure there's 2 possibilities. So unfortunately, we got to do the problem now. We'll solve for B, solve for C. So the acute angle, that refers to B here. So our answers are going to go here first. The obtuse version, that's going to go over here. That's our second triangle. This is our second triangle. Okay, let's solve for our first triangle first. Sine of B over 35 is equal to sine of 47 over 34. Please take a look at how I decided to set up my law of sines. I start off with an angle I don't know over the side and following the same fraction for the pair I do know. This is all calculator work. Let's take out the calculator. Darn it. I'm going to type 47 sine divided by 34 equals times 35. That's not an angle I need. We're going to undo it. B is 48.83. 48.83. And that's the acute angle they're talking about in the question. The question is saying, find the acute angle. That's this version of the triangle. So we know what angle B is, 48.8. 48.83. That's our angle B. How do I find angle C? Well, since we have A and B, we can find angle C by subtracting to 180. So 180 minus 47 minus 48.83. And we're left with 80 84.17. If we have my third angle, I can find my third side using law of sines. So it's sine, oops. Since that's a side first, C over sine of 84.17 is equal to 34 over sine of 47. 34 times 84.17 sine equals divided by 47 sine equals, and we're left with C is 46.24. 46.24. I'm going to double check this by just comparing the sides and the angles? Do small angles have small sides? And do large angles have large sides? Small angles, yeah. Small angles, small sides. And large angles, large sides. And that's one quick way for me to make sure this makes sense. Okay, off to our second version of this triangle. So the second version is, remember, I'm going to draw this triangle. Let me draw this out first, then I'll erase it. 1, 2, 3, and 4. So our next version is this other outer worldly version. I'm just kidding, it's not. We still have 47. We still have the sides 35 and 34. Remember, this side is also 34. We said the acute angle was 48.83. So how does that get us this triangle in here? We subtracted from what number? 180, and that automatically gives us the angle we want, 131.17. If I know two angles, we can find the third one. Plus 47 equals, I want to minus this from 180. Turns out my third angle is a really tiny angle, 1.83. Let me do that again. 180 minus the 48.83 gives me my obtuse angle, which is 131. We add that to the angle 47 that's already there, and we subtract it from 180 to get our third angle. So it's 1.83. Now I can find side C. C over sine 1.83 is equal to 34 over sine of 47. So if you take note here, if you notice, probably didn't, but if you notice that these are exactly the same setup, I'm still solving for side C for both these triangles. I still went and solved for angle C for both these triangles. The angle that linked them together, the acute angle here and the obtuse angle here, that's what links these two triangles together. And that's where we have two different possibilities. Calculator work. This is just going to be 34 times 1.83 sine equals, and divide that by 47 sine equals. And we're left with a C side of 1.48, which is a pretty small side. Let me do it one more time. 34 times 1.83 sine equals, divided by 47 sine equals, yeah, 1.48. Okay. So we just did two examples of how to solve for ASS triangles. If you need more help with this, you can definitely watch this video again. If you need other examples, you can type in YouTube ambiguous triangles, and you'll find examples like this, like what we just did in Google. Okay. If you also need help, you can always email me. But the idea is that you practice about 6 of these different versions. So you get used to the practice. It's actually the same type of question over and over and over. Now here's one problem that you might come up with. Sorry, I'm at my tip. If you guys, thank you for bearing with me just a little longer, just a little bit longer. If you end up with an ASS triangle that looks like this, if I say 32, 8, and let's give ourselves a number like 2. And you try to solve this problem. If you look at 2, 2's too short, and it never touches the ground. There's no way for 2 to make it to the ground. It's too short. So what happens is this triangle does not exist. D, N, E. Now, how do you know that? It's when you plug into your calculator. And on the homework, you will come up with triangles that are D and E. So if I set this up, let's solve for angle, call this B again. Sine of B over 8 is equal to sine of 32. Sine 32 over 2. If I plug this in my calculator, sine of B is equal to 8 sine of 32 over 2. 8 times 32 sine equals, divided by 2 equals. If I inverse this number, it gives me an error. That means this triangle might not have been obvious, but was too short, and it is impossible for us to get that angle. It is impossible for us to come up with an angle that can force 32 to be 2 and this angle B to be 8. Doesn't exist. If you end up with an error, it's because the triangle does not exist.